Bismillahirrahmanirrahim. Welcome to Being Guru Electrical channel in the question and answer series. Today we'll discuss some interview question answer. So I will recommend you to watch the complete video because we have a series of 10 questions. In these 10 questions, if you go to any interview, maybe you will ask any of these questions. I'm sure because this is my personal experience. So before going to start the video, if you are new on the channel, so subscribe the channel and turn on the notification by clicking the bell icon, so you will receive the channel notification timely. So now let's start. So the question number 1 in the today's session is why single phase voltage is 220 volt and three phase not 660 volt. Because if we have single phase 220, so we have three phases, so multiplied by 3 make it 660 volt. So why it's not 660 volt and it is 415 volt? So to see the answer of this question, we need some mathematical representation of this. We have single phase power equals single phase voltage times single phase current. So if you multiply both sides by 3, so 3 into single phase power is equal to 3 into single phase voltage and single phase current. So 3 into single phase power is equal to under root 3 times single phase voltage multiplied by under root 3 times current, single phase current. So this will convert to 3 phase power, and under root 3 V single phase will convert to under 3 phase voltage, which is phase to phase voltage, multiplied by under root 3 times single phase current. So this under root 3 came from this under root 3 came from here. So simply 3 phase power formula is under root 3 V times I. Some people ask, I already made one video on this earlier. So one student asked, there is cos theta. So this is apparent power, this is not active power. If it is active power, you can mention here cos theta, the power factor. So this is the, so now simply we have this formula, so multiply under root 3 by 220, you will get 415 volt. So this is the reason why we have 3 phase 415 volt and not 660 volt. So now moving to next question. Next question, we have important factor for paralleling of transformer. This is important. If you go to any substation, there are transformer connected in parallel, so they are equally sharing the load. So if you want to connect the transformer in parallel, each transformer should have same voltage ratio. Their primary voltage and secondary voltage should match. Second, we have same vector group. This vector group should be same for all the transformers which are to be connected in parallel. If it is different, so the transformer, it should be not connected parallel, it should be separate. Then we have same percentage impedance. All the transformer connected in parallel should have same percentage impedance. If this is different, it will create imbalance load sharing. Like if this is different, one transformer will supply more power and the other will supply less power. So this percentage impedance allow the transformer to distribute the load evenly on each transformer. So now next question, we have difference between AC current and DC current. This is also basic engineering question, and also it is I was asked in the substation about this current, what is the difference between AC current and DC current. So AC current is defined as the flow of charges per unit time at specific frequency. Okay, we have same formula for I is equal to Q divided by T, charges per unit time. But in case of AC, what's the difference? It's specific frequency. If you see the DC current, flow of charges per unit time, I is equal to Q divided by T. And in AC current, this is flow of charges per unit time. It's the same, but at a specific frequency. So this is the difference in the AC current and DC current. Now question number 4, we have why overhead transmission line conductor are not PVC insulated. This you can see in the transmission line. All the transmission conductor in the overhead transmission are bare conductors. They are not covered by PVC insulation. So what's the reason of this? This allows the conductor to cool easily because air will pass through the conductor and it will cool it. And if you cover it with PVC insulation, this PVC insulation will block the cooling by the natural air around the conductor. Second, we have, because air provide the insulation, so we don't need the PVC insulation because air is the insulator itself. And the third one, if we make the PVC insulation, it will increase the weight of the conductor. So also it's increasing the weight and it increasing the load on the towers. So these are the main reasons. Question number 5, we have transformer is linear or non-linear machine. This question I was asked in the interview myself. Like either transformer is a linear device or it is a non-linear device. So transformer is a linear device. If you have one transformer, you can use it as step-up transformer or step-down transformer, but you need to make the power frequency should be same, because if you have 10 kVA transformer, so if you can use only 10 kVA if you are using a step up or step down. In both cases you will take 10 kVA from the transformer, either if you use it step up or step down. Next question we have, why PLC is used in industrial processes. If you go to any industry, you will see the PLC controller there. So why there? In some industry you see PLC, in some industry you don't see any PLC controller. So if you, in any process, if you have more inputs and more outputs, then we use PLC, because in the PLC we have internally relays, we have internally timers, we have counters. So we minimize the size of our control panel by using the PLC, because all the timers, counters, relays come inside one unit which is called the PLC, and it is easy to make the changes in the process without altering wiring. If you use the PLC, you can only, and if you want to change some process, you want to change some threshold values, so you can only change the values in the program, or you can make the changes to the logic. So without altering the wiring, you can achieve your desired process, you can achieve your desired changes in the process. If you use the PLC, there will be less relays, there will be less timers, counters, so your panel size will reduce and you have less maintenance and high reliability, because more wiring, more relays, more timers, it will increase the wiring and it will increase the maintenance time, and the reliability is high if you use the PLC. Next question we have, what is the difference between 2-winding and 3-winding transformer? This is the important question in the electrical interviews. What is the difference between 2-winding transformer and 3-winding transformer? So let's see, 2-winding transformer is a distribution transformer. There are only two windings, one is primary, one is secondary. Primary is receiving the power and through secondary it is giving out the power. But in 3-winding transformer, what is there? 3-winding transformer normally is an auto transformer, and the primary is star configuration and the secondary winding is also star configuration. So due to this, to trap the harmonics, the third winding is add, which is called a tertiary winding, and it is in the, you can make it delta connected to trap the unwanted harmonics. So this is the main difference between 2-winding and 3-winding transformer. 3-winding transformer you will always see in the substation, and it is a transformer used for the regulation of electricity. Next we have, which motor rating is recommended to use star delta starter? At which motor rating it is recommended to use star delta starter? So above 15 HP motor, star delta starter shall be used. Below 15 HP motor, you can use direct online starter, but above 15 horsepower, you should use star delta starter. You can also use star delta starter below 15 HP, but it is not recommended to use DOL above 15 HP motor. It should be star delta or any other soft starter you can use. Why DC battery backup are used in substation? So DC battery backups are used in the substation to ensure continuous supply to control appliances even during blackout or power failure. In the substation, if we have any blackout condition or power failure condition, so to ensure the continuous power supply to control appliances, the appliances include relays, initiation, it may be protection equipment, anything that are controlling the transformers, circuit breakers in the blackout or power failure condition. Next we have what is the difference between switchyard and substation. This is the most commonly used question if you go to the powerhouse or substation, because switchyard and substation it look like similar. Today we will see what's the difference. In switchyard there are no transformer, only there are circuit breakers which can be used to turn on or turn on the supply. Only you can control the supply here. In the switchyard we don't change the voltage, we only cut the supply or turn on the supply. It is only associated with the powerhouse. In the powerhouse we have a switchyard to control the supply at the output. Now the substation is used for the voltage regulation. In the substation we have a power transformer, and for power transformer from the on load tape changer we can change the voltage at the output of the transformer. And also substation is used for the transmission and distribution purposes. You can take the transmission line from the substation, or you can take a distribution line from the substation. So this is the purpose of substation. Next we have what is the purpose of oil in distribution transformer. The purpose of oil in the distribution transformer is, the first one is cooling. It ensure cooling inside the transformer winding, because it take heat from the transformer winding and bring it up, because the hot oil goes up towards the conservator and the cool come down. So internally this circulation of oil ensure the cooling of the transformer winding. Second, we have insulation. The purpose of oil is to provide insulation between the windings and between the winding and the transformer tank or transformer body. So this is the second purpose of the oil. What is BIL? BIL is basic insulation level or basic impulse level, and it is used to test electrical equipment for withstanding against lightning strike transient. You have noticed that in the thunder storm condition, the lightning strike hit the electrical equipment. So this BIL is the value to which the electrical equipment are designed, so that can withstand these lightning strikes. It is normally 95 kV is taken as a standard in Pakistan, and 75 kV to 125 kV depending on the region is taken in the Middle East. So this is all about interview questions. If you have any question regarding this, you can let us know. And if you have any interview question of your own which are not mentioned here, you can give us in the comment, so we will discuss that in the next video. If you didn't subscribe now, and like the video and share with your friends, and see you soon in the next video.